Hi folks, so the question we're going over today guys comes under the topic of oblique planes, and this comes out of the DCG workbook. It's on page 113 and it actually is oblique plane sheet 13, okay? So the question itself says, the given solid has been cut by an oblique plane. Locate the traces of the plane and produce a true shape of the cut surface by rebatting the oblique plane, okay? So based on our other videos that we have done at this stage, this is kind of a little bit of recap work for us, okay? So when we know we have an oblique plane cutting through a surface here, and we can actually see the solid in this case is probably a square base pyramid. Just looking at the plan here, we can see obviously we have a square, and we can see that it's obviously sitting on the XY line, it's sitting on the ground. And we can actually see the surface as it's cut here in the elevation, and we can see the cut surface here in our plan view as well. And basically on both of those, that basically is kind of indicating us the inclination of the oblique plane. Now we don't know the exact angle of it, we would actually have to find the traces to do that, and that is the first part. It's telling us locate the traces of the oblique plane and then show the true shape by rebatment. Okay, so first of all, this cut surface here, I'm going to label it. I'm going to use letters to label it. I'll start off with plan, and I'm going to call it, this point here is A, B, call this one C, this one D. If I have it labelled in plan, label it in elevation, so A is up here. Then we had B down to C here, and D here. Okay, so starting off we need to find the traces. So what I'm actually going to do is, if I continue any one of these edges, A to B, B to C, D to C, A to D, if I continue one of those edges, okay, down to touch the XY line, that is actually showing in fact a point where it hits the XY line. That is actually a point on the horizontal trace where the oblique plane is cutting through the horizontal plane. So just trying to pick the ones that are most appropriate here, and I think BC would be a good one. So I'm going to extend down BC here. Going to continue that down, and at that point there on the XY line, that is actually a point on my horizontal trace. Now we need to find that in our plan view. So technically where it is on the XY line, it will be directly below that, and whatever I did in the elevation, I have to continue that also in plan. So if I extended BC in elevation, I will also extend it in plan. And as we can see there, where the two lines intersect one another right here at this point, that there is actually showing us a point on the horizontal trace right there. So if we've it done for one, okay, we still don't know the angle of the horizontal trace, okay, of where that line is cutting through, or where the oblique plane is cutting through the horizontal plane. So we've found one point, so we're going to use the same method to find another. Now I could use, just thinking here, AB, if I was to continue that down, it would hit here and come down. Yeah, it would come down. It's probably going off my page a little bit. Not off my page, but out of camera shot there, but AB. In this case then I'll actually just use DC, because I think that'll actually work okay. Yeah, so I'm going to continue down DC, extend that down, hits the XY line right here. Where it hits the XY line, project it down to my plan, and the exact same in plan, I need to continue that edge as well, as it would appear in the plan view. And as we can see there, once again we have another point now. Now technically, if I was to join those 2 points together and continue it on, okay, that actually gives me my horizontal trace. Just for the sake of it though, I just want to see how accurate I am. I'm going to try and continue the edge AB down. Just see. Now I know it'll go out of camera shot, but I just want to see will it work. So if I extend that down, then come down here, and I'm going to extend it down here as well. And I found that, as you can see there, it actually stays within camera shot. Now technically that's a third point on the horizontal trace. I just want to see, do they all line up? And they do. So I know I'm happy with that then. As long as they all line up, I'm happy. So that's actually 3 points on the horizontal trace, so I did it for AB. I do think probably using maybe BC and then AB would be better. I think it's more accurate because now this worked out, but I think when you've distance between the 2 points that you found, it probably gives you a more accurate horizontal trace. Okay, so there we have the horizontal trace anyway, first of all. And having found that, we can now find our vertical trace. There's two ways you could do it. Okay, we'll use the same method that we did down here. So in the case of, I'll do it for A and D this time. I'm going to continue AD, and I'm going to extend it on until it hits my XY line right here. Where it hits the XY line, that is a point on the vertical trace, okay, as it would appear, because the XY line is a wall as we look at it in our plan view. Okay, I'm going to extend that up, and I'm going to do the exact same and extend AD here. And as you can see there, that there is a point on my vertical trace. So having found that, I can now construct it. Right there. Mark right there. And there we have our vertical trace. So that's the first part of the question, VTH. Another method we could have done there, and this is the one I would usually use, okay, is when you have a point, or when you have the horizontal trace, to find a point, or to find a point on the vertical trace. Let's say I was using A, I could have gone parallel to the horizontal trace from A, where it hits the XY line, project it up, start there, where it hits the XY line, project it up, and technically from A here, I should be able to go across. We can see that they're matching up there, okay? So that would have given us a point on the vertical trace. So now what I'm actually going to do is I need to rebat the plane around and find the true shape of this cut surface here, okay? So for that, what I'm going to do is I'm going to take the height on my auxiliary, and I'll actually use this height here. Might as well, it's just the easiest. So I'm going to put that in green there. I'll take that. Okay, and what I'm going to do is I'm going to rebat that around. So by taking this, it's a point on now the vertical trace, and we're basically flipping it down until it's flat on the ground, until it's on the horizontal plane. So I'm rotating it around like that, and going to project out perpendicular to the horizontal trace from where it is on the XY line. So rotating perpendicular to the horizontal trace. You can see it's there, right there, okay? And that there now is the vertical trace when it has been rebatted onto the horizontal plane. So I'll call it V1. Okay, so now our oblique plane is this, okay, when it's been rebatted down. And on that oblique plane we obviously have the cut surface, okay. So we've done this previously, okay. There's a couple of ways you can do it. I'll do two methods once again. So let's say for the points C and B, okay, to find C using the rebatment, okay, well it is all rebatment. For C, I'm going to project that across where it hits the vertical trace right there. I'm going to, using T as kind of my anchor point, my compass point, I'm going to rotate that around where it hits the vertical trace when it is in my plan view, okay, or as the oblique plane is sitting. I'm going to go parallel to the horizontal trace, and we're using C here, parallel to the horizontal trace, and then from C here, perpendicular to the horizontal trace. And technically now I have now found C1. I'm going to call it C1 there. And I could do the exact same method for B. So for B, we'll do it now. And for B, I'm going to, once again, where it hits the point on the vertical trace, right there, I'm going to rebat that around to where it is on the vertical trace when it is on the ground, okay, or on the horizontal plane I should say. And once again, going to go parallel and then perpendicular. So this is for B, so parallel, I'm just thinking, yep, and then perpendicular. And there we have it. That there now is B1. Okay, now the other method is, okay, what we can do for the other method, just to show you, okay, you could continue that on now and do the same for D and A, okay, but it's just good to show you both in the video. So for D, I could go parallel to the horizontal trace to where it hits the XY line. Where it hits the XY line, go perpendicular to the horizontal trace. Where it hits my V1T, go parallel to the horizontal trace. And then from D in plan, perpendicular. And there we have it. That is another method there. Okay, so as you can see there, it goes kind of here. I put an arrow there to where it hits that. Then I go perpendicular. Okay, and where it hits this point here, we go parallel once again. So you can see it's kind of going around in a step and then out here from D here. I'm going out in this direction as well. Okay, and helps us locate that point. But you can see here it's essentially rectangle. Okay, I'm going to do the exact same for A, and I've it already done. So line it up with my horizontal trace, which was already done. I had that done previously, so I went parallel to where it hit here. Going to go perpendicular to where it hits out here. Where it hits out here, parallel, and from A in plan, perpendicular. And there we have it. So that was two methods shown you there, both rebatment. So now I can heavy that in. A to B, or A1 to B1 in this case, B1 to C1, C1 to D1, and then finally D1 back to A1. And there we have it, guys. That is true shape cut surface. There's the true shape of the cut surface. Okay, and that was done, guys, by rebatment. Okay, so a little bit in that question, guys, nothing that we haven't done before in these videos on the oblique plane. Okay, where we had to find the vertical trace, the horizontal trace, and then use the rebatment method to find the true shape to show the cut, or sorry, to show the true shape of the cut surface. Okay, so what we're going to do now, guys, we're going to move on here over to the right hand side of the page and start with question 2. Okay. Right, folks, so in this question here, what they're asking us, guys, is, it says, question 2, given are the partial projections of a pyramid cut by an oblique plane VTH. Okay, so we can see here we've obviously got the elevation view of the pyramid. It's incomplete at this moment in time, and then the plan view also, where the base has been completed, but obviously the kind of cut surface here, which we don't have yet. And then obviously our vertical trace, horizontal trace. An auxiliary showing the edge view of the plane is also shown. So we can see here this is an auxiliary view, and usually an auxiliary will be signified or shown by an X1, Y1. Okay, so I'll just put that in there. And obviously the auxiliary view is showing a point view of the horizontal trace. So right in there, that's actually a point view. So I'm going to write that in. A little arrow there. That is a point view of HT. Okay, because we looked along the horizontal trace. So point view of HT. Okay, the horizontal trace. And it says here, complete the projections of the solid to show where it is cut by the plane, and then rebat the oblique plane on the auxiliary to locate the true shape of the cut surface. Okay, so something slightly different here. Just on the second part, okay, the first part we're kind of working backwards because we're given the auxiliary. So just on that there, guys, what I'm actually going to do is I'm going to focus on the first part and then I'll get on to the second. Okay, so first of all, what I'm actually going to do is I'm going to heavy in my auxiliary view, just the bits that I know I can. Okay, so I can heavy in that edge, heavy in this edge, and heavy in this edge here. And then obviously we have hidden detail in here. So just put it in as neatly as I can, as they have done on the sheet. Okay, so obviously we can see here that is our auxiliary view kind of completed, and we can see obviously the kind of greyish area. That's where the oblique plane is cutting our pyramid. And obviously in this view we see the oblique plane as an edge view. Okay, so this is our V, then this is a point view TH. Okay, so it's an edge view. So where it's an edge view, this is helpful because that's actually showing to us the exact cut points on our pyramid. And obviously because it's once again actually we have a square base pyramid here. And we can actually see then they're obviously all joining up to the apex. So obviously there's just 4 kind of edges that are connected up to the apex. So I'm actually going to use labels, and I'm going to call all of them by letters. So I'm going to say this is A. I'll actually label it here first. I think it'd be better. So I'll say A. Let's go around in circular pattern. B, C, D. So if I label them, A is obviously up here. Let's work this out. D, because we're looking in this direction, we can see D is up here at the front. So there's D there at this point. B is at the back, so that's the hidden edge, because obviously we're looking in this direction. B is at the back. Then C is the outside one here. Okay, so what we can actually locate is the cut points. So on the A edge, the cut point is right there. On the D edge, the cut point is there. B, the cut point is here. And then on the C edge, the cut point is up here. So it's very easy. Let's project those back to our plan view. Okay, so line it up with the horizontal trace. And for A, it's going to obviously be back here. So there's my A. For the D one, it's going to be down here. For B, it's going to be here. And then for C, it's going to be this guy. Okay, so having located those, just make a little mark on them. I can then connect all them up. So this obviously looks like very much like the last question that we previously did. So what I've actually located here is the cut surface of this square base pyramid. Now they haven't told us it's a square base pyramid. They just said it was a pyramid. And having done that, now I will heavy in my edges as far as they would go up to. So that's the plan view done. Okay, let's heavy in that a little bit further there. Extend out a touch more. And having found the plan view, we now need to find the elevation. So to find the elevation, same process, just work it up, follow your edges. So once again, A is here, so it's here, B is up here, and then I'll C on the outside, and then D here. Okay, so same process. Let's find where it cuts on A, which is right there, so it's up here. Where it cuts on B, and C, and then finally D. Okay, so to locate them, right there, find right there, here, and then just about there. Okay, so let's heavy those in. Let's see all them. That'll connect to here, which connects up to here, and so on. And once again then heavy in our edges as we would see it in our elevation view. And finally this hidden detail edge back here. I'll put it in a little bit quicker this time. So that's the first part of the question done there, guys, where we have completed the projections of the solid to show where it is cut by the plane. So we use obviously the cut points here, 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 and here. We projected them back to our plan, and then having found them on our plan, we could project them up to our elevation. So now the next point we have to go on to is, it says here, rebact the oblique plane on the auxiliary to locate the true shape. Okay. So previously what we would have done was we did the rebatment method where we rebatted the vertical trace until it was flat down on the horizontal plane, where we took a height here, okay? Now they're asking us to do something slightly different, okay? So what I'm going to do here is I'm going to actually extend out my x1, y1. Okay, I'm just going to continue that out there. And what they're actually asking us to do is essentially just rebat the oblique plane on the auxiliary. So essentially, look, from here to here, that section right there is actually our cut surface, okay? Which is, I'm actually going to label it with letters, or sorry, numbers this time. So I'm going to call if A1, so then it'll be B2, C3, and then D4. So I'll label them up here. That would have been 1, that would have been 2, 3, and then D to 4, and so it'll be the same here. So A to 1, B to 2, C to 3, which is here, yeah, just want to make sure I'm going right, and then 4 is here. Okay, so technically that cut surface there, we're seeing it as an edge here, as a line, essentially. So where 1 is, where 2 is, where 3 is, where 4 is, the cut surface, okay, is from here to here. And all they're asking us to do is, they're asking us to rebat it, okay, on the auxiliary view, okay. So essentially this here is going to be our hinge point, where previously we used this on the last question, okay, as our kind of our hinge point. We're essentially just going to take this surface, which is here, like it's a door, and we're going to rotate it around. And we're going to do that for point 1, point 2, point 3, and point 4. And I'll start off with, I'm actually going to start off with point 3, just because it's probably the easiest. Okay, so just to show you here, just because it's the furthest away. So for 3, and with my point right here, okay, on the point view of the horizontal trace, I'm going to mark out up to 3, and I'm going to rotate that around. And essentially all I've done is I have rotated 3 until it is flat now on the ground, because still our x1, y1 is our ground. Okay. At this point I'm going to project that point right there parallel to the horizontal trace. So just line it up with the horizontal trace. Once again, remember now at this point now it's going to seem quite similar. And then parallel, and then where it is in plan view, perpendicular. Let's extend that down a touch further. So there we have it. There is our point 3, or however you want to call it, maybe 3-1. I'll call it 3. Okay, there's our point 3. Okay, on the true shape. So essentially all we did was we rebatted it down, but you have to remember, even though we've rebatted it down, okay, onto the ground, this is still on the ground, so we're still seeing it as obviously an edge view. So what we need to do is we need to then project it down parallel to the horizontal trace, and then project out our points perpendicular to it. Okay, so we follow that method. So I'm going to do the same for 2, and for 4, and for 1. So for number 2, I'll start here. I will put in the arcs the full way. Do the exact same for 4. And then the exact same for 1. And there's our 1. Okay, so same thing, parallel to the horizontal trace for all of them. So this one was number 2, so just thinking how far I have to come, about to here. The next one was number 4, so he comes a little bit further. And then finally the next one was number 1, so about to here. And for all of them then perpendicular. Oh, just moved it slightly there now, so I have to make sure I'm still accurate. So for all of them perpendicular. So for number 2, which was all the way out here, for number 1, which was here, of course it should slip, and then finally for number 4, which is down here. So there we have it. I'll label them now. There's number 4, there's number 1, and there is number 2. So there you have it, guys. 1 to 2, 2 to 3, 3 to 4, and 4 back to 1. And once again, true shape, cut surface. Okay. In that one there, guys, as you can see, that is just slightly different from the previous method we did on the other page. That probably, guys, is the fastest way. Okay, both methods are absolutely kind of the same kind of thing. We rebatted both of them technically. Okay, only difference with this one in comparison to the previous one was, in the previous one we rebatted around our vertical trace. Okay, in this view here, in this question, sorry, what we did was we got our oblique plane as an edge view, and what we're actually showing here is the true inclination of the oblique plane as well, okay, in relation to the horizontal plane. Okay, so that's actually its true inclination there. By doing this method here, okay, this is technically a little bit quicker. Whereas we still could have done what we previously did in the other question, where we took a height and then we rebatted around the vertical trace until it was on the ground, and then projected down to find it down here, and we could have gone along the same route. You would not lose any marks, but what you're actually doing is you're just probably adding in a couple of extra steps. Whereas in this one, we see it as an edge surface, okay, here. So 1, 2, 3, 4, we're on the edge surface, or the edge view of the oblique plane. And it was very simple then just to rebat them down until they're flat, and then at this point project them down parallel to the horizontal trace, and then obviously projecting out perpendicular, okay? It's just understanding which one is best to use in the circumstances. Anytime you have an auxiliary view, okay, used, this is possibly the quickest way, by where we're just going to rebat it around the point view of the horizontal trace, okay? Once again guys, I hope you found them helpful. That is the questions complete there, okay.